Hello, everybody. I'm Kelly from FLIR Systems, and I would like to welcome you to today's webinar. Our presenters of today will be our very own expert in the field, Christian Pehl, and our invitee, Lars, who you might know as the Swedish fire nerd. Please note that if you're watching the webinar from a mobile device, that you swap the shared screen with the video in order to see the presentation correctly. During the presentation, you can ask your questions through the Q&A function, which you can find at the bottom of your computer screen. At the end of the presentation, we'll try to tackle these questions. I won't make the intro any longer than needed, and I'll pass the stage on to Christian and Lars.
Yeah, thank you very much, Kelly, and everyone. Welcome to our second webinar. We had one yesterday, and this is the second one here. Welcome, everybody. Good morning, good evening, and good night, because we have an audience all around the world. And Lars and I will actually talk about thermal solutions for the modern fire services. And we would actually tackle 3 questions today. So first questions is actually how a good TIC can radically change search and rescue practices. And what is the difference between a good and a bad TIC? And the third question is how a good TIC can improve suppression and other tasks that we are doing in the fire services. So I just jump in, and we are actually looking at the first videos. And Lars, I would like you to start and go ahead and raise the first question.
Well, thank you. You know, and I termed the question, I phrased that as how it radically should change search and rescue practices. If we look at a video like this, if you were to ask me, when I started in the fire service, we had, I remember my basic training, we had the solo TIC. It was the yellow helmet you could put on. It was just like, it went over your face. It was integrated with a mask. It was actually very revolutionary. But if you looked at the image quality of that camera, it was at best a situational awareness camera. You could see roughly, you know, if the smoke wasn't too bad, you could roughly see the space you were in. And if you look at a video like this, we can see here, you can see like every bit of detail in the room, even though that the image starts to go, the visual image starts to go when we open the doors, start suppression. But even though we're still producing a lot of water when we start suppression, you still have visibility in the space you're in, and you can assess like temperatures and so on. So it really is, it has become a game changer for how I look at firefighting as a whole and training of firefighters, also as an educator of firefighters. And this question here is one of where I think that one of the most radical changes is, at least how I perceive my message as being received when I teach, like how to change search and rescue to be more effective.
Yeah, thank you. I think we already see a lot of details in that first video, and how firefighters can behave and enter the fire compartment, and that is already a radical change in how we actually were approaching the scenarios in the early times, right? So let us have a look at the second video here. Yeah, what?
You know, it's another slide.
So that's another slide. So what are the topics that we would like to cover actually in these how the search and rescue practices can be actually made easier or more progressive with a TIC?
Well, when I think about like me teaching firefighting, you know, these are 4. You can divide this into multiple ways, and you know, like, but these are 4 key points I would say as being heavily influenced by the TIC evolution, the TIC development. Like, how do you identify entry points? You scan the building from outside and you see, where do I see the most heat? Where do I see thermal columns coming from? And try to decide, like, if I look through a door, for instance, is this the best entry point? And maybe find alternative ways of attacking the fire, maybe with a piercing nozzle, like a high pressure system or a fog nail. be able to implement that in the same time as I do an interior tack, for instance, and having that tick as a something to make that decision a lot easier a lot of times. But one of the most radical ones is that when we go inside, I was taught to do wall-oriented searches, and when I go around the world, a lot of times that's what firefighters being taught as the basic, and I am a big proponent of a tick-oriented search as the basic for how we operate, meaning we see the fire, we see where the heat is coming from, and we go straight to that rather than keeping your right hand in the wall or left hand in the wall doing wall-oriented searches. And we'll get into that more. But also the case, of course, for risk assessment. When modern fire PPE became so good that you can't even really feel that sudden increase in heat, it's just very hard to react early to suppress that heat with water before you start getting saturated gear and becoming too hot. But with the thermal imager, you can react much sooner and try to suppress that heat. And if you can't, you can start to back out. So the risk assessment, if you want to go or no go, or cool or not cool when we get to fire suppression, I mean, it's a game changer in terms of if you go from no tick to a good tick. And as we said, fire suppression, now I can see where my stream is going. I know where the water is hitting and so on. And we'll get more to that. But these 4 key areas for me has been, I would say, a really big thing for me to try to implement in training and how I think about tactics and methods on the fire ground.
Right. Thank you very much for that. And I think we jump right in there and have a look at the next video. And if you could actually just describe what we see here. So.
Yeah, this is from a inquiry structure burn, and this is very early. We just light the fire, and we can see in the ceiling in the fire compartment, like even this early in the fire development, we can still see things happening in the thermal imager. We see that thermal layer start to grow, and I was taught that you couldn't see smoke. You can't see smoke in the thermal imager. You can't see gases, but if I look at like the K55 camera, I can. Even though I can't even see the smoke, I start to see things happening in thermal imager. Like, why is that, Christian? Like, what happened in the development that made me that possible?
Yeah, I think we can jump on that in more detail in the technical part. But with a thermal imaging camera, we're always picking up surface temperatures. So, and of course, in a smoke layer, we always have particles involved, and that is actually what the camera is picking up, those particles, surface temperature on the particle, and that's actually moving in the smoke and in the heat currents, and that's why we can actually pick up that heat with the thermal imaging cameras. With older cameras, you probably won't be able to do that. With the new technology, and especially with our image enhancement that we have in our cameras, you can actually pick up these heat currents. And I think that is a real game changer. And if we look at the next video, it's not necessarily that we actually have this with hot air or with hot smoke, but if you look at that video, we're talking about an average temperature of 80, 90 degrees, so like a sauna temperature, and it's not very hot, but you can see the air movement here as well, right? So that means it doesn't have to be hot smoke, but it needs to be air that is moving that we can already pick up with the thermal imaging camera. And if you look at that image here, you can see the heat built up on the ceiling, and you can actually follow that heat flow into the direction of the fire, because the heat is always moving away from the fire, right? So that's
most
something...
of the time. But it really is. That's the thing. Well, sometimes fires do strange things sometimes, but it's just mind-bogglingly complicated. But anyway, it is so important for me as a firefighter to be able to find the fire. And when I was taught firefighting, I was taught, follow the wall, and basically you could listen a little bit, and then you start maybe seeing flames. But it was a slow process working your way through the room. But if I have that ability to see a thermal column, to see convective heat in those particles coming from somewhere, or I see a heat source somewhere further away, and I could go straight to that, it's such a night and day difference in terms of how fast I can get to the fire. So the technical ability, and don't ask me how it works, the technical ability to actually see that flow, again, as me as a firefighter or as an educator, it is a game changer, because if I want to do things faster, if I want to, for instance, ventilate, I need to suppress that fire as fast as possible, which always means I need to find it as fast as possible. So that ability is really cool. And if you move to the next slide, you know, that where we're going to start to see a little bit more smoke, still not a lot of smoke. But if we have this hallway here where the firefighters are sitting, and of course I'm sitting behind them. It's again an acquired structure burn. We're just waiting for the fire to build up. And if I look in the ceiling here, I see smoke circulating in that space, and it's very hard to visually see where that smoke is coming from. But if I imagine myself coming into that compartment as a firefighter looking for the fire, in the thermal imager, I instantly see that thermal flow coming out of that compartment. And I know very fast that I know I need to go to that door, maybe close it or maybe open it, get some water in. I'll start to indicate that, you know, I start to get up to orange colors and see that, you know, that there's some substantial heat coming from that doorway. But again, it's the first really big thing is just finding where does all that smoke come from. I'm not saying that you always can see that thermal flow. It depends on the development of the fire. If it's going down in intensity, the thermal flow is getting slower and slower, maybe harder and harder. But especially if you have a developing fire, you know, window breaks, or you're arriving early in the fire development, you're going to see that thermal flow coming from that fire department, from that fire compartment.
Right. All right, so let's move to the next video here.
Yeah, and that's just, again, it's not an acquired structure burn. I'm sitting in that room, and again, if I arrive as a firefighter and I come into this fire compartment, this secondary fire compartment, and I'll see instantly, where do I want to go? Where do I want to put my stream? I see two doorways. Of course, the fire is coming from the right. It's so obvious in the thermal imager, but it might not all be obvious if I don't have visual sight or limited visual sight. And second, of course, I can see that fire is, when I arrive in that room and when the video starts, it's rolling in the ceiling of that room, but it's rapidly developing into a fully developed fire in that compartment. And it starts to roll out and coming above my head. And with the thermal imager, I can react way faster in terms of putting my, for instance, stream into that compartment, start to cool it before it starts to roll over my head, and I started getting surprised that there's a lot of flames and so on. Because again, if I don't have visual sight, through the thermal imager, or for that matter, visually, I don't know. I don't know when to start to cool. In that case, I would have to cool all the time, which might be a problem in terms of creating just an unnecessary amount of water damages, for instance.
Right, and that video is only a few seconds long, and you can see how quick the heat actually builds up and is actually moving out the door, which you cannot visually see in the smoke, right? So,
not at all.
Right, another video we have here is actually checking a door and using the camera to check the ventilation or flow path control. So what do you see here?
Yeah, this is my video, as you pointed out earlier. It's me at the door here, and we're doing a training burn again. The fire is on the other side of that door. I'm using the door as my tool to control the fire development, and we're looking at the ticks, looking at fire flows. We're going to do gas cooling and so on. But you can really see that of course the fire inside the fire compartment, visually you can't see anything right now. That's why there's no visual camera. But as soon as you start closing that door, you still see the thermal flow coming out of that compartment. And when I close that door down, the fire just goes into decay instantly. And again, as my first thing, if I go around the corner and I see that open door, I can go straight to it and I can close it and instantly have that effect, instead of, for instance, going right-hand searching around the room and getting to the fire compartment and then closing it. And it's those little things, you might say, but it's make a huge difference on the fire ground in terms of how fast I can operate. And now, of course, the fire is I let it develop until it shoots out of the entire compartment. Then I close it down, suppress it a little bit, and open it again, and it comes back. You know, and now it's the dragon that comes out. And I can really see it if I look at it, if I sit by that door, we close it, you can really see the pressure differences going inside that compartment. When I close it, you get overpressure, and I close it down, you see it starts getting negative pressure, and then it starts getting overpressure. You see that typical backdraft scenario. You can really see that in the thermal imager.
All right, thank you. So another topic we would like to discuss is actually that, you know, there's not only thermal imagers for interior tech and fire suppression, but we also offer imagers for officers, in example, to help doing a 360 investigation around a building. And we have tools that are suitable for something like that. And I think a thermal imager can also radically change the approach here. What do you think is the radical approach here, Lars?
Well, I mean, it's if you look at the pictures on the right, you have there, like if you have a building that it's not tight or not super well insulated, you will definitely start to see heat signatures on the outside of the building. Like when I compare it, if you go back in time in Sweden, we were taught to do, we will wet the door, because if you get steaming coming from the door, you know it's hot on the other side. And we don't really do that anymore, simply because insulation on the exterior doors has become so good, or, you know, like feel it with your hand, has become so good that it would be a massive fire in there for it to feel anything. But then when I asked my colleagues in Spain and the southern part of Europe, they go like, yeah, we do that all the time, and it works great. Like, because they have papier-mâché doors, like they have beautiful weather all around. They don't need a ton of insulation. So a lot of times, even though the building is closed, if you live in a climate where you don't have super much insulation, you will see it at the doors and everything. In Sweden, we will instead see it at all the vent points. We will see it not on the door or cracks. We will see it, for instance, in a vent point. We can stand on the outside and see that fresh air vent that usually sucks air in is coming heat out. And we can indicate that there's something going on around that area, in that room or that part of the building. So the ability to scan already from the outside and put a fog nail in, a piercing nozzle, or just select where to entry, or in extreme cases, this high-rise building, if we can already from the ground see that we have a fire, maybe it's built through an open window, there's no smoke coming out yet, you see the heat, maybe it's on the balcony, maybe there are cracks or something that allow you, or extreme cases, maybe you can see it actually on the surface of the window, if it's really hot. I mean, that would be indicated you can call on more resources. We have developed fires, you know, get aerials in, or, you know, develop that drone you bought from China with the dry cam in from the outside. I had no idea, but you know, but you have that already as an officer. In that case, you have that ability to start assessing the situation earlier than you would without thermal imager.
Saving a lot of time on that one, just moving up the stairs all the way and doing an assessment up there. So that will save you a lot of time. Another thing you can actually do with this officer stick is actually detect oil spills on a street. An example, at night, you will see the same difference like during the day. Inspect hotspots on machinery or on railroad cars, an example. Overheated brakes that can cause fires on rail tracks, an example. You can detect leaks on containers or on hazmat trucks that have been rolled over. Or you can also detect cold spots. decompressing gas is an example where we have cracks in pipes or so, or in cylinders. That's something you can also detect with a thermal imaging camera, and that can help you make a really qualified decision as an officer there. All right, here we have two different technologies compared with each other. On the right-hand side, we can see the regular technology that all the TICs on the market for firefighting uses, so regular thermal imaging. And on the left-hand side, we see a combination of a visual image and a thermal image. So the ability with the visible image actually is giving us the signs that we can read, writings, notes, and everything, or marks on, let's say, circuit breakers or electrical boards. And that can be a huge help as well if you want to make a qualified decision. So technology can also help us to improve our ability to see what is going on right now and make qualified decisions. Okay, so then we want to touch the next topic. What is the difference between a good and a bad TIC? And a big topic there is actually we want to discuss today is the image quality. Why is image quality so important? And is really resolution everything on a good TIC, or is the bigger the resolution, it must be the bigger TIC? And what is image enhancement? What does it do for us as firefighters? Why are we using only 3 colors at FLIR? And what is actually the difference on the modes? Or why can a mode help us, or maybe even confuse us? Yeah. And then we want to touch up on the temperature reading. Is a higher temperature reading on a TIC always better, or can it also be worse for us? Yeah. Right. So there's different thermal imaging cameras on the market, and it's not only that all these cameras serve one purpose. So we have cameras that we offer with a large display, with a high resolution, with a high refresh rate, where you have the ability to see those heat currents that we have actually touched before. And those cameras are made for tactical decisions. So really go into the fire, making go, no-go decisions, make the decisions to back up or actually pull the staff out, right? Then there's lower budget versions that have a smaller display, not as a high resolution, but they're made for fire attack as well. And they are made for situational awareness, so that you know, okay, I can find a door out, or I can find a window in case I need to get out, right? And then there are these lower budget versions that do not have that high resolution, but can help an officer to make a qualified 360 investigation and also documentation what is going on that fire ground. And of course, with the distance to the fire going down, the temperature is going up, and that cameras need to be tested and need to really be made for firefighting approaches, right? And why is it so important that you have a good image? Why is that so important for you as a firefighter, Lars?
Well, it's a very obvious question first, you know, like the better image I have, the faster I understand what I'm actually looking at. If I, like in this video, when you see the fire here in the corner, the firefighters, we are sitting here doing some pulses and looking at smoke layers and so on. Now, is it important that I can see like the screws on the gypsum board? No, but it gives the space where I'm in reference points. It makes it easier to just see how the space looks like. And when I start placing water and so on, of course, these small subtle differences that you can pick up with a good camera, then I can see where my water is, and I can see where I put my water and when I need to put my water, if it's getting hotter or colder and so on. So image quality is, of course, essential. And what I discovered fairly early was that it's impossible to look at a spec sheet and decide if it's a good camera or not. It's like, that's fairly useless It's like I'm a hobby photographer besides thermal imagers also, and it's the same thing. You can't spot a good camera just looking at how many megapixels it has. That has value too. I'm not saying it doesn't have value, but if you look at the two different cameras, the image quality is just so different depending on, I guess, I have no idea how you do it, the technology inside, like software. What is all your programs doing, Christian? I have no idea. But again, if you look at this picture, I can actually see exactly how that thermal layer is developing. Even though we have flames in that compartment, we'll see more later, I can see basically a little bit through the flames, even though I see the heat of the flames. And I can see how the space looks like behind the flames, and like what am I actually placing my water at, for instance.
Right. Another interesting thing, and actually in that compartment, is that if you look at the left upper corner here, that we have like turbulences in that upper corner, and the heat is building quite a huge amount of heat is actually building up here in that left corner. We'll see that later on from another angle, and I think this is also an important part that we don't forget also to look behind us, because even if we're approaching the fire, it can happen that we have a heat buildup just behind us, right?
Yeah, and that's when I do a lot of quiet structure burn, especially when you have older buildings and the ceiling is painted. You start to rain down fire behind you because the flakes of paint is coming behind. Because again, like you said, there's a heat buildup behind you where it's accumulating that convective heat. So yeah, it's fairly common that you get fires. I mean, I'm not saying all the way down to where you entered. I'm just saying 1 meter, 2 meters behind you if you don't pay attention to where that heat is going.
Right, so let's have a look at, and I think we can already see how much that heat actually built up here. So we're roughly around 400 degrees Celsius. And if we jump to the next video, that is actually the same room, just from another angle. And you can see how the heat is actually moving towards that corner and is actually building up that heat over there quite a bit. And I think you can also see how the heat currents or the flow of the heat is actually going out the door, and as it passes that door frame, we have a heat built up in the door frame as well that is quite high here. And if you can imagine, if you walk in there upright, you're exposing yourself to a temperature of 400 degrees with your head there. And you made a good comment yesterday. You can feel it a long time, but once you feel it, it's there really quick, right?
Yeah, our gear it's not too good. That's not the way of saying it, but it's so good that we don't feel sudden heat. We're insulated, so we don't feel that it's suddenly getting hotter when it starts to ignite above our heads. And a lot of times when it ignites above your heads, you can't even see it because the smoke is so thick. So if you don't see it, you're not doing anything. And when you eventually start to feel that heat 5 seconds later or 10 seconds later, now you've saturated your gear, and it's really, if you start cooling now, you're still left with all that heat in your gear. You can't get it out. So again, like the ability to act early is such an important thing for firefighters to be able to keep going, in the sense that we're not accumulating that heat inside our gear.
Right. So you were talking about that image enhancement earlier, and I want to point that out a little bit into detail. What is image enhancement? Image enhancement is actually a real-time software program that is actually converting the signals that we're getting from the temperatures into a sharper and crisper image. So if you look on the left-hand side, the image, it's a little bit blurry. You cannot see a lot of details. You can't imagine what is going on. But if you look on the right-hand side, with the FSX technology that we're using, it's called flexible scene enhancement. It is actually sharpening the image quite a bit, and that's a really good approach. You can even see the droplets on the helmet here. You can read the name here, And especially if we are looking through the flames and behind the flames, you can see a lot of details in the background, and you can actually do a good estimate what is going on there and how the room looks like. And I think that is a very important part for us to make a go, no-go decision, or really a qualified attack decision, how we're going to place the stream. Another thing we were talking about earlier is the ease of understanding the image. So what we are doing at FLIR is actually we're using 3 colors to point out the temperatures. From 150 degrees to 300 degrees, we're doing a yellow color, and it's like a traffic light more or less. You can say, okay, yellow is actually still okay. You can still move in. Orange, you got to be aware, because in a temperature range 300 to 450 degrees, our personal protection equipment is getting unstable. The mask of our polycarbonate shield on a breathing mask is actually starting to cook at around 400 degrees Celsius, and that's where the polycarbonate starts bubbling up. And that should be an indicator for us if we are seeing firefighters with a surface temperature of above 300 degrees, it's an indicator to move back, right? And 450 degrees and above, we are indicating in red as a signal color. Okay, stop, don't move in any further. This is a really risk. You should not move in any further. Try another approach, how to get in, or how to actually place your stream there. And people should always remember our fire gear is maybe flame retardant, but it's not fireproof. And it will break at one point or melt. And the other thing you have to keep in mind, it's not our protection equipment that will probably fail. It is actually our own body that will actually fail first, because our core temperature is the big problem. The core temperature is increasing, and we can't get that heat out of our gear anymore because it's too hot outside to get that body cooled down, right?
Yeah, if you start building up that heat, you're left with it, basically. And I mean, we do that a lot we do container training. You know, like we do a rollover or something, and you build up heat and you feel hot, and then you ventilate the container. And if you have a door to the fire compartment, you close that, and afterwards you take your glove off and you feel that there's no heat left in the container, and you're sitting there going like, it's so hot. And then the students really feel that, like, if you accumulate heat, you will suffer for it for the rest of the incident, and you will not be effective for very long. Because again, as soon as that core body temperature rises, you're done. You're not making good decisions and so on. So yeah, it is really important to understand. Now, that sudden impact of heat, sure, you can take that. Our gear is phenomenal. Like, it's not fireproof, but it's so good. But you will suffer for it. You won't die. You probably won't even damage your gear. But like you say, the core temperature of your body will go up. And again, that you will suffer for it.
Right. Okay, so another topic I would like to touch is actually the modes we are using in our TIC. So we have in our K55 an example, we have 5 different modes, and one of them is actually the black and white mode, where we have no colorization, and we distribute the grayscale colors from -20 degrees to 650 degrees. And if you compare that with the regular firefighting basic mode, where all the KXX models start up, if you switch them on, and you compare those 2 images, I think it's very easy for firefighters to understand what is going on the right side versus, you know, okay, I know it is actually hot here, but, you know, it's not really visualized. But on the right-hand side, you can see, okay, red there, it's really hot. You can clearly see the structure as well. And you can actually make a qualified decision again, what to do here, right? And if I compare the same situation with different modes, so we see exactly the same situation, I put in just different modes here, and again here up on the left upper corner, there's the firefighting basic mode, it's very easy to understand what is going on here, versus black and white. Okay, I see and I know white is hot, but no, it's not that much information. With the red, with the colorization, it's just easier to understand. Versus on the right-hand side, there's two modes that doesn't help me in that situation at all, because I will just see red all over. I'm not able even to detect the real temperatures that we see here, because we are in the person search mode here, yeah, but I'm looking at a fire. And what happens is actually the thermal imaging camera, if you look on the left-hand side here, you'll see those triangles, yeah, facing upwards. That means that the camera is in a low gain mode. Versus the camera on the right-hand side, the camera is locked into the high gain mode, yeah. And what that means, I will explain later on another slide. But I just wanted to point out, not every mode is suitable for every situation, right? So you have to choose the right mode for the task that you want to fulfill. And in that case, those two won't probably help us. Yeah, there are other tasks that we can do with those modes. And what I would like to do is now touch on those high gain and low gain modes. You as a user will probably not even recognize it, that the camera is switching from high gain mode to low gain mode. If you're approaching the fire, the only indication you have is actually that green triangle you see in the left upper corner of the camera or on the display. And what happens is actually that we are comparing here the raising temperature with the sunlight. So if you're out in the sunlight and the sun is not too bright, you can stand outside with your regular eyes, with your regular vision, and I can compare that with a temperature of -20 to 150 degrees Celsius. Yeah, that is, the tick is actually reading. And if the temperature is actually raising, you can compare that being out in the bright sunlight using your sunglasses, so you can still see everything perfectly. But you're protecting your eyes, you know, not getting that energy of the sunlight into your eyes that much. And the same happens here with the camera. It's switching to low gain mode, and you can have temperature reading from 150 to 650 degrees Celsius perfectly here, right? But what happens if you are having higher temperatures? If you have higher temperatures, you need to apply a filter in a thermal imaging camera. That's just physics. And what happens here is actually, it would be like you being out in the sun, having your sunglasses on, and additionally put a welding shield right in front of your face, and you can perfectly look into the sun, but you can't see a person right in front of you anymore. So that means if you're doing higher temperature readings, you're losing information on the lower part. And that's something that we would like to avoid with our thermal imaging cameras, because there is not really a big difference in the approach how we're gonna extinguish a fire if it's burning with 650 degrees or 1,000 degrees, right? So if you compare these two tick ranges and resolution in example, on the left-hand side we have a 320 resolution, on the right-hand side we have a 384 resolution, so even a higher resolution on the right-hand side, and higher temperature reading on the right-hand side. But if you look at the images of the two cameras, you can clearly see that you see a lot more details on the left-hand side. You can see below the fireplace. You can see even that baby doll lying on the ground here, which you probably will not be able to detect with the right-hand camera. So losing a lot of information around that fireplace, you can see, okay, the camera is showing me a higher temperature, but what is more important now? Is it more important now that I see the higher temperature, or is it more important that I see the more details, right? And I think if we're looking at the next videos, we think we can make actually a qualified decision with a better image, right?
Yeah, and I just if we look at that video, that's from another structure fire that I did, a training burn. You can see on the bottom right, you can see that's the temperature, the K55, FLIR K55. On the top right, there's another camera, and I could just, from my perspective, when I look at it from an educational standpoint, I do a lot of videos where I try to, show what's happening and so on. So from an educator standpoint, we can see a massive difference in terms of the image quality. Basically, what am I actually seeing in that ceiling in that hallway? As an educator, again, that's invaluable for me to see what happens if I put a stream there. How is the flow moving in the ceiling? Now, if I'm a firefighter, I need to quickly go into that hallway and I need to scan that ceiling, and I need to do two things. I need to evaluate what kind of temperature we have. Do I need to cool? And both cameras will solve that in that case. Both cameras indicate you need to cool. But the difference is with in this case, the bottom right corner, I can see, even the shape of the hallway in the ceiling. I know instantly how that room looks like, much quicker, much easier, rather than the comparison on the top right. So I agree when you say, like, if it's 650 or 1,000 degrees, I have no idea what to do with that as a firefighter. It makes no difference to me. Maybe if I'm, doing, like metal works and I need to know exactly what temperature metal is, then I would need it. But as a firefighter, I don't see a point. So I don't really care about what the temperature max is. I just know that for whatever reason you're telling me, technically that's true, but I just know the vision just looks a lot better. And if you look at the next slide also, that's, again, we're looking at the difference between the two different cameras, and same situation. You can see the firefighters on the other side of that fire compartment. And now we have a small fire. We just have a little bit of flow coming out of the fire compartment. And in the middle picture down there, again, is the K55. You can see the separation between the smoke and the ceiling. You can see the wooden boards in the ceiling behind, and you see that thermal flow coming out of the fire compartment. And again, as a firefighter, I'm going to make that turn, and I need to assess where is the fire coming from. I know instantly it's going into that hallway into the left. With the camera on the right, I see a sloping plane. And maybe I can, from that information, I can judge that it's coming from left, but I can't see in the same clarity that how that smoke is flowing out of the compartment. I can't see anything about how high is that ceiling. I don't know if there is a ceiling in that place. Like, is it just above in the hallway, or is it a hole there going up to the second floor? I have no idea. So the information I get from that picture is just way better for me as a firefighter and educator, regardless of your technical shenanigans.
Yeah, thanks. You have a good point. With the FSX technology, I can even identify that there is a wooden ceiling probably there. You can see the wooden boards, right? So with other technologies, you might not even be able to see or see anything there. Just, okay, it's hot there. That's it, right?
Yeah, and again,
okay.
That level of detail, I mean, it may be not important to me even to see the exact layout of the ceiling, of course, but I get instant situational awareness, like there is a ceiling there. I can orient myself in the space, which is, again, quickly do that with a quick scan.
Right. Okay, another topic we would like to touch today is actually how a good TIC can actually improve suppression in other tasks. We've been discussing that yesterday as well with the stream placement. The TIC can actually really help us in fighting the fire and making qualified decisions on where to place the stream and where to approach the fire, right? So we have another video here. You're using the nozzle and cooling down that room.
Yeah, again, I'm doing a quiet structure burn. There's a fire, and of course, it's coming from the left in the compartment. You even see in the thermal imager, I put a smoke blocker, or basically in this case, it's just a fire blanket to keep a little bit of smoke inside the fire compartment, because I want to build up a smoke layer for this evolution. And there's also a board there, and which comes down, which is not intended, but so there was a lot more fire than I anticipated. But in the thermal imager, you can see the hallway, you can see actually the fire blanket, rolling in the top, you can see the board coming down, but you can see that when I'm moving my stream, my objective with that, when I'm sitting there, is to make sure that it only burns in the fire compartment, and we kind of spare the hallway a little bit. And with that little bit, you know, like that's a little bit of garden hose I'm using there, which is super smooth for me as an educator when I just want to pinpoint water just in the right place, because I don't want too much water, because it impacts on my fire behavior. I want a certain fire behavior. I don't want too much steam, for instance. And with the thermal imager, I can just pinpoint. I know where I put my water in the ceiling and where not. So I know which surfaces are wet and which surfaces are not. And I can see that with thermal imager, which is pretty awesome, and it's very useful as an educator when I set my scenario. But of course, it's the same thing when if I go into as a firefighter, if I paint the ceiling, you know, with my stream, and I whip it back and forth like a straight stream or a fog, afterwards I can actually see where the water is going and where it ends up, and if it stays there, which is just phenomenal.
Right. Another thing I would like to point out is actually in the background, right? Just if you look through that hallway or what it was, you can see through that actually hallway and see even behind the flames that there are firefighters back there, right?
Yeah, that's another group that's watching the fire behavior,
right?
And as you see. Now, and someone said to me, you can't see, like we talked about before, you can't see gases and everything. Go like, yeah, you sure can see flames and fire. And if there's too much fire, if it's really rocking, you can't see through it because there's so much carbon particles in the flames. You'll actually only see the surface of the flame, basically. But then you need a lot of fire, like we have
right.
at some points in this video.
Right. Okay, so thank you on that one. There is another one from Amada Byrne, and I think that's a really good point, where you can see how the fire is actually involved, and how you can actually even use maybe your stream to push the door open or so. Yeah, what happens here, Lars?
Again, another training burn, another house, another day, another fire, another good day. We're building. Yeah, it's a good day when I see fire. What can I say? I'm a nerd. So we have a fire, of course, in the end of the hallway. If you play that, there's the camera to the left is actually perpendicular to the fire. It looks across the hallway, but on the camera to the right, you'll see the same image as the camera, the tick camera in the middle. And we can actually see the firefighters on the right really don't see what's going on. But in the tick, you can see through the flames, through smoke. You can clearly see that there's a doorway in front of them. They can see if that doorway is open or if it's closed. You can see what's happening inside. You can direct a stream through that door, maybe suppress it, and then open up. And in this case, at the end, there's an external attack. There's actually a stream coming in from the outside that suppresses that fire. But again, the ability to see where I'm going, where the heat is coming from, and actually place my stream in the ceiling, get some water on the ceiling here to get it wet, and into that fire compartment and suppress this. It's just, otherwise I'm just guessing. I'm just spraying water everywhere. And that works too most of the time. But if I want to be surgical and, for instance, limit water damages, the ability just to place enough water in the right place is an awesome ability. So simply by doing that, it is a game changer.
Right. Okay, thank you for that one. And another one we have from an outside view as well, and an inside view.
Yeah, that's another training bird, another day. And then this time we're doing gas cooling with a fog, and you can see, of course, as soon as the fire develops in that corridor where the firefighters are sitting, even though they're sitting like a meter inside that hallway, visibility goes to zero, the top left corner. But in the thermal imager, you can constantly see the surrounding space. You have situational awareness. You see where the doorway is. You see the ceiling. Now, when there's a lot of steam and water building up, the pictures start to degrade. But it comes back when it flows out. But in terms of fire suppression, you can see I'm cooling and the fire comes back, and I'm cooling and the fire comes back. It's cooling and the heat comes back. Sorry, and you know roughly when you need to start cooling and when you can advance. And as soon as you get into the fire compartment, you get a permanent improvement of the heat conditions. But again, like the camera on the left, when I try to capture that as an educator, it's useless. I can't see stream. I can't see the effect of the stream. I can't see if we're effective or not. But with the thermal imager, I can show that like this is what is happening. And we can discuss like nozzle practice, like in stream shapes, straight stream versus fog and so on. We'll not get into that now. But the ability to know what is happening roughly, it's not a thermometer, it's definitely not, but it's an indicator of what's happening with the heat above my head in front of me. And again, it just adds another layer of how I can, as an educator, show something, and as a firefighter, I can be effective at doing what I'm supposed to do, in this case, fire suppression.
All right, thank you. And then we have another video from an outside perspective. Unfortunately, not a visual video with it, but I think we can touch on it that firefighter did not have a thermal imaging camera in his hands. So what can we see here?
Yeah, this is an outside view, and again, we're doing like this is at the end of one of the burns we've done. And we're just playing basically, and the firefighters is tasked with suppressing the fire, and they put water in different windows. But without thermal imager, if you don't see clearly where the fire is coming from, if you don't have clearly, flames shooting out of a window, it might be hard to judge where do I put my stream, where is the most heat to get the most bang for the buck. Now, of course, in this case, if they would put the stream on the bottom floor, that would have made most difference in just this particular case. But if there's multiple windows on the bottom floor, there's smoke coming out of each of them, where am I closest to the fire? Where are the most heat coming from? With a thermal imager, I can go straight to the hottest, the probably hottest window and affect the fire here. Now, there's a question here on the Q&A I want to touch upon straight away, that on all the cameras, or the videos I show, there's this, it's a static camera. It's just the matter of, I put it on a tripod when I make videos. I put it on tripod because the video becomes so much better. Not the quality or the image quality, it's just that it's stable, which allows me to match up two visual pictures with a thermal imager, and I can draw graphics on it, and arrows and airflows and so on. If I handheld it, it's like it's shaking. So it's just that I use a tripod for capturing good training content.
Right, and that was actually, we should say hello to some guys from Oslo, because we have some firefighters from Oslo joining. That was one burn that we did in the Oslo area, right? That was
yeah, it was not Oslo Fire Department. It was Øvre Romerike Fire Department, which is just outside of Oslo.
Yeah. All right, and I think one thing I would like to
burn, yeah.
Right. One thing I would like to point out is actually the vent points we were discussing earlier. If you have like good insulated doors or windows, here we can actually see two vent points, and that's something we probably could pick up with a lower resolution camera and officer's camera as well, if we're doing a 360 search. Of course, at that stage, it's a very late stage that doesn't matter. But I just wanted to touch that this would be the points where we could probably also detect a fire in an early stage if we're doing a 360 search. All right.
Yeah,
and then
in Sweden we either have those holes or just slits around the window. It's more common around Europe, and those are the places where you usually get air in. But at a fire, you will probably get heat out. So that's one of the areas where you will see that.
Right. And then one of the most wonderful videos I've ever seen with thermal imaging camera.
Yeah, it's me in the container, and I'm in a container from a French company. It's a great container because I can play with smoke layers here, because I can maintain the heat and I can get good conditions. In this case, I'm playing with a flammable smoke layer that is not explosive, it's not fast, it's just barely flammable. And you put that heat source in, and you can see that we're getting ignitions in the smoke layer, and then in the thermal imager, you can clearly see it spreading out and slowly burning. But visually, it's just glowing through the smoke layer a little bit. And if the smoke layer came down even more, you couldn't see it at all. It's just magical. It's just, I would call it epic. And again, I'm a nerd, but I love it. It's just fun. It's just interesting. But again, like the capability of seeing things through the smoke, what happens behind the actual smoke layer, what happens above our heads. Again, it's just phenomenal being able to do that. And as an educator, I can show stuff that I could not have done otherwise. It's invaluable to me.
Right. Right, thank you for that one. And then there's another one from the Oslo area where we want to touch on other tasks. What can you actually do with the thermal imager? Touching on, you know, how a dangerous situation can actually spread in other areas.
Yeah, and this is you shooting the video, Christian, as we figured out.
Yeah.
You were joining me and joining this burn. And there was by the end of the burn, and we're gonna, you know, this house is burning down, and you follow the air currents coming off of the fire. You can really see those glowing ambers from the fire, how they're traveling with the thermal column and just going far away. Now, to be able to assess like how much flying debris do we have in the smoke, how far are they going, where are they landing? It's just another thing that I would never thought about. Like, you know, it's another way of using the thermal imager, the fire, as an officer to assess the risk we have of, you know, igniting, you know, forest fires, you know, like grass fires, or even other building fires. Just a great tool to have.
Yeah, and just to mention how far the spread was, actually, we could detect those particles like 200 meters away from the actual house burn, right? So it was very far. So that means if you have brushes or dry grass 200 meters away, that actually can spread into a brush fire or a forest fire even, right? So you need to make sure that you have someone checking that all the time, right? Okay, another thing I would like actually to point out is actually we've been discussing a lot of firefighting applications now. Of course, we're firefighters, but we're also responding to other scenarios. And one thing I would like to point out is actually, and give a little teaser maybe on some of the following webinars that we're doing, how can you actually use a tick in other situations? So what I'm doing here is actually I'm putting brake cleaner on a bucket cover, and visually you cannot see anything here, right? But with the thermal imaging cameras, you can clearly see that liquid flowing down that lid, and you can see it is actually getting darker and darker over the time. So with the thermal imaging cameras, I can detect hazardous materials, an example, easily combustible liquids, an example, that are evaporating. And over the time, if it's getting darker, we know, okay, that substance is actually maybe a combustible substance and is evaporating fast, and we can actually take action to avoid any further spread of the scenario here. And another thing I would like to point out is use your tick also in like car accidents. We had car accidents with our department where, you know, we approached the scene and there was nobody there, so we couldn't find a victim. And with a thermal imaging camera, you can see how many people have been sitting in your car, an example, and you can make a qualified statement to police officers that are asking you, okay, how many people have been in the car, or was there a baby in a baby seat, an example. You can see clearly how the body temperature was heating up the seat here on the driver's seat, but on the passenger seat there was nobody sitting there, because you can see the seat heater, the coils of the seat heater here very sharp, and there was most definitely nobody sitting in that car, right? So another scenario where we can use the tick, and we will touch up on that with some of the following webinars, and maybe even explaining some more technical details on how the ticks work and how you can actually use them in our emergency services, not only for firefighting and fire suppression, but also for other tasks that we're doing in the fire department. All right, so I think it's time to draw some conclusions. I hope we had some answers here on those questions. So Lars, what's your conclusion for this webinar?
Yeah, the reason I picked sort of these three questions, and it's that I sort of wished for these, is the first one is, and why I really want to have it radically, is that it is perceived by some to be a radical change. For instance, if we go from a tick or from a wall-oriented search or tick-oriented search, I was typically taught to go right-hand side or left-hand side wall, follow the wall, because you need to maintain situational awareness. You need to have a safe place to go and so on. It was our way of making sure that we're sort of in the right place and so on. And now ticks has become so good that I'm very, very strong in my opinion that we should go straight to the fire. Now, first off, the most common question I get or pushback is, what happens if the tick fails, Lars? Well, then you'll go back to the wall along your hose line 2 meters and follow the wall. It's not harder than that. Now, if you don't have a hose line with you, it might be a bit different, but usually you have a wall behind you you can go back to. But anyway, and the other one is, well, the firefighters needs to be good at searching with the basic is the wall-oriented search, and you go through the whole course of fire training, and you do search and rescue, you do fire suppression, you do ventilation, and then in the end you're giving the recruits or the firefighters a thermal imager, and they're going, why didn't you show me this to start with? Like, this is much easier. I can see what I'm doing. You should start it. The basic version, what's basic for firefighter is a tick-oriented search. Now, the backup, that's the wall-oriented search. That's the thing that you shouldn't be as good at. You should be proficient. You should be safe doing that. But we should be really good at the tick-oriented search. Like if I was a driver and I go, well, you need to be really good at the horse and carriage, because that's the basic. If the automobile breaks down, you need to take the horse out. No, like, we've made that switch. We're good at the automobile. Like, if that breaks down and you have a horse and you can ride that horse safely, awesome. But you need to be good at the car, meaning we need to have a good tick, and we need to really make sure that that's top priority. Now, the difference between a good and a bad tick for me is, like, don't try to use a situational awareness camera as a tactical camera. You can't judge a fish by its ability to jump or fly. Like, it is not meant to be that. And so a K55, like, for instance, that's a tactical camera, and that's the thing you want if you want to make tactical choices, follow air currents and so on. Now, is a K2, like a situational camera, better than nothing? Of course, it's a radical difference in terms of finding your way in through the structure. So to pick a camera that is good enough for what you intended to do. And again, like, difference between what I've seen, as an educator, and why I use a K55 when I shoot videos is just, this is just a superior image quality compared to many other cameras that I've tried. And I've tried basically all of them in one sense or another. Another third question is, how can a tick improve suppression of the task? Again, the ability to be able to guide my stream, know when I should, start flowing water, and where, in which direction, and so on. I'm not saying that always works. You don't always have a clear image in your thermal imager where the heat is coming from. Sometimes you get so much particles you can't even see your thermal imager. It's not a, it changes everything, but for most cases it's a radical game changer. And again, in training, firefighters need to start straight away with having the tick working together with the nozzle person, like a two-team approach. You don't have, until you get me a small thermal imager I can put on my helmet or something, I need 3 hands right now. So how number 1 and number 2 firefighter works together, it's like you have to bring that at the start of firefighter training. Just as you do with search and rescue, you need to have it at start. It's not something you add on later, because it shapes everything as how you look at how the team works inside and so on. So it is, for me, a radical shift. in terms of how I train firefighters and how I look at firefighting if you had a good tick in your firefighting team?